Hi, and welcome to the Kontena live webcast. First of all, sorry about the technical difficulties. We've had some crashing video equipment, so hopefully it's going to be okay for the rest of the talk. So today the topic is how to build a fully automated continuous integration and continuous delivery pipeline using containers, using Drone.io as the CI/CD system, and then using Kontena platform as the runtime environment for the containers. Without further ado, let's go for the slides. In the slides, I'm gonna have first some background things, and then I'm gonna go briefly through Kontena platform, what it is, what's it all about. I'm gonna explain how Drone.io works, and then in the demo part, I'm gonna show how to deploy drone service on top of Kontena platform and how to configure and use that for building your containers and delivering those into runtime environment. So first of all, why are we really building things with containers and orchestrating the full pipeline with drone and Kontena? So basically what you have to have is really flexible tooling to control your full life cycle of your application. It really matters because it gives you quite a lot of agility to go from git commit to production really easily and really fastly. Typically, when you build your pipeline for your build process, you have few different steps in there. You of course you test your application. You have some runtime dependencies during the testing. You have to launch, for example, a database, and then you have to execute the tests. In the build part, especially when using containers, you typically build your containers, you push them to some hub somewhere, some Docker image register somewhere, for example, Docker Hub public. And then after you published your images, you deploy them to your production environment or testing environment if you automate that also. And the deployment part is typically quite tricky because it consists of multiple different steps. So of course you have to launch new containers based on your new images. You have to typically register them to load balancing, remove all containers, and then configure the load balancing so that the old containers wouldn't get any traffic anymore. So those are really things that you want to automate because nobody nowadays wants to configure anything manually anymore. And that's basically where Kontena comes into the picture. So just to briefly go through Kontena platform, because the topic for today is mostly focusing on the continuous delivery pipeline. So Kontena is an open source platform, so to manage your containers and microservices. It's really built on the sort of promise to maximize the developer happiness. So whatever we do in Kontena, we try to make it super easy to use for developers. Kontena platform works in any cloud or basically in any environment where you can run Docker. It's really easy and simple to set up and to use. In the Kontena platform, the most important concept is called a container grid. So it's basically a set of nodes that you launch in some cloud or in your private data center. And we combine those as one big Docker machine, basically. The nodes can be actually located anywhere. They can be running on single data center in Amazon or Google Cloud, or you can actually spread your nodes across different cloud providers. You can even spread the nodes so that you have some nodes in private data centers, some in public clouds, and this sort of hybrid combination of things. Kontena creates automatically an overlay network on top of the grid nodes. So what it basically means is that whenever we launch a container in whatever node in the grid, the container is always attached to the overlay network. And this really creates an easy to use networking solution for the containers, because the containers now don't have to understand anything about the network. The containers can talk to each other as in local subnet, regardless of where they are actually running. So as an example, my container web application could be running on the node on Amazon Cloud, and my database can be running on my private data center, and the connection is actually made as in local network from the container's point of view. Kontena also configures DNS-based service discovery for all the services running on the Kontena platform. And we do also have an etcd key value store available in the grid automatically if applications need this key value based service discovery. All the services and containers running on Kontena platform, they get a DNS address. So finding where my database is running is actually pretty easy with using the DNS entries. Kontena, of course, takes care of the orchestration for the containers. So Kontena makes sure that all the containers that are supposed to be running are running somewhere in the grid, and automatically it also tries to balance all the services within the grid so that the loads are evenly distributed across the nodes. On top of these different sort of architectural layers, then you can run your containerized workloads. In Kontena, services can be composed together so to form these complex elastic applications. And of course, you can scale your services up and down depending on the need and on the load of the service you are providing. On the node level, the only thing that has to be running on the node is a Kontena agent. And actually, the Kontena agent is just another container. Of course, it has to have some superpowers so that it can actually control the underlying Docker engine on the host. The agent itself, when it starts up, it can then fully orchestrate all the other parts it needs on the node level. The agent automatically configures the overlay networking and all the other parts that it needs. The persistent state of things is stored in Kontena master. So the Kontena master has the sort of brains of the system. So the master takes all the decisions for the orchestration and distribution of the containers. The master provides a REST API, and Kontena automatically, of course, provides a CLI tool which you can use to control your Kontena environment. We do have a web UI in the makings, and of course, as the master provides a REST API, it's pretty easy to integrate anything to control the master. The Kontena master can also be installed in highly available setup if needed. So you can run multiple instances of the container master, and as the data is stored in MongoDB, it's pretty easy to set up a, let's say, 3-node MongoDB replica set so that the data will be always available. It's also good to know that if for some reason the container master goes down, whatever services are running in the grid, they will continue to run and operate normally. The only drawback so it's just one CLI command to spin that up within your grid. So it really provides you easy to use a registry for your private images. As the overlay network by default is only available within the grid, and of course sometimes we have to do some database maintenance operations or things like that. So Kontena also provides a built-in VPN access point for the overlay network. And again, it's one single CLI command to set up the VPN access point, and you can then access it with any OpenVPN compliant client. Kontena comes also with the built-in load balancer. It's built on top of HA proxy. So it really provides a fully automatic zero downtime service to balance the incoming load for your services. So whenever you scale up your service, the Kontena load balancer is always automatically updated and starts to distribute load to the new instances of your service. And of course, any other change is always automatically reflected to the load balancer configuration. So no need to tweak any load balancing configurations manually or with any scripting. Kontena gathers all the statistics and logs for every single container that's launched on top of Kontena platform. So what it really gives for the user is really easy to use way to check what's going on in my service at this very moment. Of course, the idea for Kontena and the aim for Kontena is not to provide these huge analytics capabilities. So if you need further analytics, for example for logs, if you use Splunk, you can then easily stream the logs out of Kontena platform and then use some other analytics tools like Splunk or ElkStack. All the operations done in the Kontena master are of course authenticated, and every single operation that changes the state of services are aggregated in an audit trail log. So we do have then a clear line of changes identifiable with the audit trail log. So we can see who changed what and when, to be able to track down some issues in the deployment, for example. Kontena also has a built-in secrets management solution called a Kontena Vault. So you don't have to anymore have your MySQL password in any configuration file. So you can securely store passwords and certificates and whatever secrets you have in the Kontena Vault. And Kontena makes sure that they are encrypted all the way through the node level, and then just as the very last step, when we spin up a new container, we open the secret and inject it into the container using environment variables. So basically, Kontena comes with all the things you don't need and want to implement yourself anymore. Just really easy to use platform that comes with all the bells and whistles to be able to run your services effectively and easily. Okay, enough about Kontena for the moment. So let's take a look on the sort of second big topic for today. So drone IO. So drone IO is really cool, quite newish continuous integration platform. And the way drone is built, it's really fully Docker based, and which then makes it really easy to install and maintain. And as everything happens in drone in Docker containers, it gives you really isolated build environment for all your different projects. And again, as things happen in Docker containers, it's really easily pluggable, because you can, of course, then execute anything in a container. Of course, drone integrates to GitHub, GitLab, and other version control providers. And it really provides this sort of a just works feeling. It's really easy to set up, and as I'm going to demonstrate in a few minutes. Why should we care about the CI thing that much? For drone, especially, it's really lightweight and low in resource usage. So it's really easy to use in any different environment. It's a single binary. It's written fully in Golang. And as said, it's really Docker native, so you can extend it really easily. All the things in drone are configured through YAML configuration, so it's really easy to read and understand what's happening in my build process. And of course, it then supports any language or any framework that you can run in a Docker container. So you don't have to install any plugins anywhere to be able to run your build for your application. So the installation for drone is really simple, because as I said, it's a single binary, just execute it. Of course, the preferred way to do it is to use Docker images available in the Docker Hub. And then the configuration is done through environment variables. The 0.5 release of drone introduced build agents, so now it's really easy to scale up your build environment to support multiple different build agents, so you can then easily run multiple parallel builds for your different applications. So the Docker way of installing or running drone, it's really simple. Of course, we have to mount the Docker socket because it spins up new containers. And that's about it. The Kontena way of installing it is to define the drone services in a Kontena YAML definition. And as you can see in the example, and I'm going to demonstrate how to do it live. So the Kontena YAML configuration is almost one-to-one to the Docker Compose YAML definition. So you define these different environment settings. You provide your GitHub client IDs, client secrets for the server part, and then for the agent part, you basically have to configure only that's where the agent actually calls home to the drone server itself. Really easy to set up. Of course, as said, drone can work with different remote drivers, so Bitbucket, GitHub, GitLab, and Gox are at least supported. And the database can be used SQLite, which is the default one, stored in the local disk, and then you can use Postgres or MySQL in more production grade environment if needed. So the concepts, what you configure for your project in drone. So you typically configure different set of plugins that operate on your as part of your build pipeline. And the plugins that you define in your drone YAML then form the actual pipeline and are executed sequentially in the build process. In drone YAML, you can also define services, and services are things that will be available for each and every step in the build process. So for example, if your application uses MongoDB, you can spin up a MongoDB service, and that will be available throughout your build process. And for each of the build containers, it will be available in localhost. You can define also a matrix build. So if you want to test your application with different language runtime version and with different database versions, you can build a matrix out of those configurations, and then drone will execute different builds with different configuration for your application. Of course, we do have to use secrets when building and deploying things. So for example, when I'm pushing my newly made Docker image to Docker Hub, I of course have to give drone some secrets how it can authenticate to the Docker Hub. And you can have also different constraints for the build pipeline so that certain steps are not executed for pull requests, and for example, certain steps are executed only when the commit is made in the master branch. To briefly go through the different concepts in a bit more detail. So the plugins are actually just Docker images. So when drone executes your build instructions, it creates this container and executes it, and basically the exit code of the container determines the success or failure of that step. So now the pipeline then is actually just a sort of arbitrary set of Docker images and Docker containers running as the build process. And you define this pipeline in the drone YAML configuration. The services, as said, are things that are available throughout the build process. And the really nice thing in drone is that all the services that are running are actually available in localhost network for all the other build containers. So for example, when I'm executing tests in my test phase, I can always be sure that my MongoDB will be available in localhost. So no need to configure anything special for the test phases. It's really handy for launching different databases using in testing phase. So the matrix, the matrix gives options to execute, for example, different Golang versions against different database versions. So in this example, I would actually execute 6 different builds. So one for each Golang version and for MySQL version combination. So whenever you are making an application that you want to make sure that runs with different language version or framework version and with different databases or different database versions, the matrix gives you really easy way to configure the build so that it actually executes the tests and build against these different combinations of configuration. So for the secrets, of course we want to keep all the secrets away from the version control system. Nobody wants to have their MySQL password in GitHub anymore. What drone does is then in the build part, it then injects these secrets into the build containers using environment variables. In drone, you actually can control the secrets in a way that you define that certain secrets are available only to certain Docker images and certain Docker containers in the build process then. So it gives you a way to control the sort of leak radius of your secrets so that you can make sure that not all containers launch as part of the build process can actually access my Docker Hub password, for example. So I can restrict the secrets injection. So in this screenshot, I defined a couple of different secrets. So for example, for the Docker Hub, you can see that they are tagged to only for the Docker plugin. So my Docker Hub credentials will be only available in the Docker plugin containers and not to any other container. For the constraints, the idea with constraints is that you limit the execution of the build steps at runtime. So for example, I of course I don't want to build my fresh Docker images probably for all pull requests or feature branches automatically. So what I can do is I can say that okay, my Docker build step in the pipeline will be executed only when the commit is against the master branch. If I'm working in a way that my master branch always is deployable to production. Or then you can limit the execution based on certain events. So if you create a tag for a release, then do some release steps, upload your artifacts to some repository somewhere, for example. Or then you can actually even restrict some of the steps using these platform specific things, so execute certain steps only when doing Windows build or something. Really easy to configure. Okay, so next I'm gonna demonstrate how to set up drone and then how to configure a simple pipeline to deploy a web application implemented in Ruby and using MongoDB as the backend. So for the demo, I do have the Kontena platform already running. It's running on DigitalOcean, and I'm acting as the poor developer doing some things. I do of course a git push for GitHub, and that then automatically triggers a webhook to Drone.io that I will set up in few minutes. And then in the build pipeline, there's a Docker step, so it pushes my freshly made Docker image to Docker Hub. And after that, we give instruction to Kontena platform to deploy these new images into production. And then of course the Kontena platform takes care of pulling the fresh images from Docker Hub and instantiating new containers, reconfiguring the load balancer and everything for you automatically. Drone of course has these status events also available for GitHub. So whenever you open a pull request, you can see that what's the status of your build for the pull request. So for the drone part, I've already defined the drone setup in Kontena YAML, and as you can see, and as I mentioned, the Kontena YAML configuration is almost one-to-one to Docker Compose YAML. And what you actually could do is that you could even import your Docker Compose YAML file and then just add the Kontena specific parts to Kontena YAML. So it provides you a really easy way to reuse your configuration, and you don't have to manage two different configurations. So for the drone server, I use the sort of official drone image. I created as a stateful service in Kontena. So Kontena makes now sure that the local SQLite database will be there even if I redeploy the drone services. I expose a port out of it, of course, because I want to access it through the internet. I give some debug environment variables so that I'm able to debug things if something goes wrong. And I'm saying that, okay, let's just now for the demo use the local SQLite database. And what I've done already in the Kontena vault, I've already imported my GitHub client IDs and client secrets. And of course, I've already configured the GitHub OAuth part in the GitHub side. Drone also needs this shared secret between the server and the build agents, so that the agents can then kind of authenticate themselves to the server. And of course I configure myself as the administrator for this drone installation. For the build agents, the configuration is even more simple. We just say in Kontena that okay, we want to launch 3 instances of the agent, because we do have some capacity available in the DigitalOcean. And in the configuration we say that okay, you can find the drone server using this short DNS name, which is automatically created by Kontena platform for the services. Then of course we use the same shared secret between the server and the agents, so that the agents can authenticate themselves. And then we mount the local Docker socket, so that the build agent is then able to spin up new containers as part of the build process. So pretty simple, straightforward configuration, especially if you've been using Docker Compose already. So let's deploy that. So deploying applications or services in Kontena is done through the CLI tool. So I'm issuing a Kontena app deploy, and now it basically reads the YAML definition, creates the services in the master, and then deploys them into the running nodes on DigitalOcean. That was fast. Let's check that the drone is available. Yes. Just freshly installed, so I don't have any configuration done yet. So let's first log in. And of course I'm logged into the GitHub already, so that it doesn't ask me any permissions anymore. To be able to control and configure drone with the drone CLI tool, I have to grab the security token. It's taking more time than expected. Yep. Let's grab that. And while we are at the admin UI, I'm gonna already enable my to-do application example repo. And now drone in the background, it already registers all the webhooks for GitHub and everything, so I don't have to configure anything manually to GitHub side. So now let's switch to the terminal and export the drone token, and just to check that the drone can actually authenticate it, the drone CLI tool can actually authenticate to the drone server now. It seems to be so, because it's able to fetch my user information, so everything should be okay. So to configure all the secrets, because in the drone configuration for my example to-do project, I do have a couple of places where I need secrets. So first of all, in the Docker build part, of course, I have to be able to push something to the Docker Hub, so it needs my credentials for Docker Hub. And then also for the Kontena deployment, because the master only allows authenticated users to do any changes, so I have to give credentials for that also. So I have prepared a script because it's too much manual typing and too error prone to do it manually. But just as an example, how to add secrets in drone is through the drone CLI tool. You say that you want to add a secret. You define that for which image the secret will be available, and what's the scope of the secret. So the secrets are always scoped to do only to specific repositories. You give the name to the secret and then the actual value for the secret. Of course, in this example, the URL for the Kontena master is not really a secret, but the secrets still give really easy and flexible way to configure things, so that I don't have to configure hard code these URLs in the drone configuration at all. Okay, so I do have a version of my application running already. So it's this really simple to do application written in Ruby, backed by MongoDB database. It's just a application to add to-dos in the list and check them out when you're done. And let's make a change to the application. Let's change something that we can easily spot that we've actually changed it. And then now when everything's, all the secrets are in place, the drone is configured to get the webhooks for my repository. So what we have to do is we have to sign the drone YAML file, because otherwise drone doesn't actually trust and inject your secrets. So whenever you make changes to your secrets, you always have to after that sign the drone YAML configuration, so that it's kind of in sync with the secrets. Otherwise drone will not trust your secrets and will actually not inject those into the containers. And just remember to sign it always before committing anything to GitHub. And when we check the Git status, we can see that the drone CLI tool creates this YAML signature file, and that has to be, of course, committed into the GitHub repo also. Let's call the change a layout fix, and then push it to GitHub. Yes, that's done. And when we go to on the drone, we can see that it already received the webhook and started to execute the build pipeline. As I just deployed the whole drone, so I don't have any caches of anything available, so the build is gonna take a few minutes to go through. While waiting for the build, we could actually take a look a bit closer in the drone YAML specification or configuration that I have for the application. So as said, it's implemented in Ruby. So as part of the test phase, I use the standard official Ruby 2.3 image, and I execute a couple of commands. First, of course, I have to do the bundle install, which basically downloads all the library dependencies for my application. And then after that, I use the rspec to execute my specs or test cases. And if that's okay and the exit code is 0, then the build goes on. If I would have failing test cases, of course, the build would be stopped because the exit code is something else than 0. The next step in my example build pipeline is to build the Docker images. For that, I'm using the official drone Docker plugin and the latest version of it. I've again given it some debug flags because I had some issues with my secrets, so I had to have some more debug out of it. I have to specify that what is the Docker Hub repo that I'm operating against? What's the image? I can also specify the tag, what tag to use for the push for the new image, and then of course the Docker file itself. So if you have some other name for your Docker file, then just configure it through the file attribute. I'm now acting as in a way that my master branch is always good to deploy to production. So I've specified the constraint that the Docker build is only executed when the commit is against the master branch. The last step in my build pipeline is the container deployment, and for that I prepared a image where I have the Kontena CLI tools in a container. It's this example is using still my private version of it, but there's actually now an official Kontena CLI Docker image available also in Docker Hub. The command is pretty simple, just container app deploy, and I've given this special -f flag to use some other file than the container.yaml by default. When I set up the test environment or the demo environment for this webcast, I was lazy to use self-signed certificates, so I have to give also this SSL ignore errors flag. Otherwise, it would complain too much about the self-signed certificates. And again, the deployment is done only when the commit is against the master branch. And lastly, in my drone configuration, I have a service defined and it's called the database, and it's actually running 3.2 MongoDB, which is then available for each of the build steps. It's only used in the test phase, of course, in this case, and in test case the MongoDB is available on localhost. So the specifications are doing something against MongoDB at localhost. So really easy to configure, actually quite powerful pipeline for your application. Of course, it can be and typically is much more complex, and you have plenty more steps in the pipeline, but still rather easy to configure and use. Let's check the status of the drone build. So as you can see in the drone logs, it first starts the database as I've given the instruction to use the MongoDB as a service in the build process. Then after that, it of course clones the GitHub repo, otherwise we wouldn't have anything to work on. Then it starts to execute the test phase. It executes the bundle install, which then downloads quite a few different libraries for Ruby. And then it executes the test cases. All three of them in this case are good to go. So exit code is 0, so it goes on to the next phase. The next phase is the Docker build. And this is where drone does things a bit differently than many other tools. Drone actually, the drone Docker plugin, it actually spins up a Docker engine within the container. So you have this Docker in Docker setup. And within the container, it then starts to execute the build. You can see that it uses my credentials for the Docker Hub and executes the Docker build with typical options. It gives the Docker file, it pulls all the fresh layers on the base images that I'm defined in my Docker file, and then starts to do the actual build. And then of course executes whatever the build executes whatever you define in your Docker file. Let's not go that deep into those. And then when the image is built, it then tags the image as instructed in the drone configuration, so given the repo name and the tag to use. And then pushes it to the Docker Hub. That's gone through nicely. Exit code 0, everything good to go. And then the last step is the Kontena deployment part. I do have quite a lot of environment variables dumped out, again for the reason I had to figure out some issues in the step. And then you can see in the last part that it actually then executes the Kontena application deployment using the clustered version configuration for the application. It updates it. Exit code seems to be 0 and the build is green. So basically when we go now to our demo application, reload it, we should see the change happened. So voila, we have a really easy to use continuous integration, continuous delivery pipeline for our containerized workload. Extremely easy to set up and to use. So as kind of a summary, the agility and the flexibility of the tools you use, it really matters, because you don't have any time to waste on fiddling with different tools and different environments. So you should really select tools that are flexible and easy to use for you. And as we saw, drone and Kontena, and especially when used together like that, they really provide you easy to use and easy to set up environment to build your continuous delivery platform. And combining these two really makes you happy. As a couple of links, you can find the example application I deployed and used in the demo in my GitHub repo. You can check that out, clone, fork it, play with it. The drone guys have prepared quite a lot of good documentation, especially for the 0.5 release. You can find Kontena meetup groups around the world to learn more about Kontena platform itself. And then of course we do have quite a comprehensive documentation for Kontena itself online on Kontena.io site. Just to note that Kontena is hiring, so if you're interested in fiddling with containers and building a container orchestration platform, check out Kontena.io/jobs. Maybe there's something interesting there. And Kontena's mission is really to become the #1 container and microservices platform for developers. To stay up to date with Kontena, you can find us on Twitter. We do have a Slack channel to discuss different things with the Kontena community and Kontena developers and engineers. As said, all Kontena parts are open source, so you can find them in GitHub. Find a local meetup group to learn more about Kontena itself, and check out Kontena website for more information. So, hope you enjoyed the webcast, and hope the technical difficulties in the start wasn't too bad wait. Hope to see you later in the later webcasts we have. Bye for now.